It's great to be here. You know, it's from past years, I know you're a wonderfully interdisciplinary group with interests all over the map. And as Jim mentioned, my charge is to do something a little bit different, a little bit more applied. I know some people are just opening our studio for the first time, and other people remember our commander. Anybody remember our commander? Jimmy over there remembers, okay. So what I'd like to do is kind of mix in some examples of how you might use online data, especially from sites like Facebook and Twitter, to study issues in health and public health, but also to kind of try to get you in the weeds enough that after these 45 minutes or an hour, you're able to kind of get yourself up and going. So Leanne is adding code to the Dropbox that is entitled DNAC code May 15th bail. And a little verbose, sorry. And that's going to take you through a worked example of getting Twitter data, building a network from Twitter. But before we do that, before you open it up and start working through it or running into the code, let me give you a few warnings. The first is that in order to access online data, we're going to need to register as developers and get credentials, something called credentials. And then also, if we make too many requests right away, something is going to happen called rate limiting. And that means Twitter is going to stop you from getting data. So before you run any of the code, please just follow along with me with some kind of preliminaries. And I promise later we'll get the code running together. So how many people here have heard of an API or application programming interface? How many people have used an API? Very few, far fewer. OK, so an application programming interface is, you can kind of think of it as a pipeline of information. It's a place where data lives, but it's a place where you can make custom requests for different types of data. Whether or not you can access that data depends on whether you have credentials, whether you're allowed to access it. So to illustrate this, I want to start with Facebook, which many folks know. And this is a tool called the Graph API Explorer. You don't have to follow along on your own machine, but if you'd like to, the URL is right here. It's developers.facebook.com/tools/explorer. And if you want to follow along, you'll have to have a Facebook account. So if you don't have a Facebook account, maybe don't bother, and you can just follow along with me. So what this is something called a sandbox. And in the computer science world, a sandbox is a place where you kind of learn or test code. And so what we're seeing here is up at the top, there's something called an access token here. This is a long string of numbers that Facebook generated when I visited the URL and when it saw that I was logged in as myself. And this long string of numbers tells Facebook what kind of data I'm allowed to get access to. Here we have a tool that's letting us make a query. A query is just a request for some type of data from an API. The simplest thing to do, I'm going to try to blow up the screen here so this is easier to see, is to write me here. And if you're logged in, you'll see here the output that you would receive from that API call. What's actually going on in the background here is a long string of URL mumbo jumbo. It's something like graph.facebook.com/graph3.0/me, and then also a long access token or my credentials. So it's really what we're doing is creating a URL, and every time we create that URL and visit it, data shows up in our browser. And so that's all we're doing here is simulating that process. We're skipping a few of the steps just for illustrative purposes. So you'll see here, this is always dangerous in a live setting, but let's see what I've been doing on Facebook. I haven't been on Facebook lately. But let's take a look at my network. So here I just added, after me, I added /friends. And now you'll see in our output window, these are the names of my friends. Interestingly, yes, I have more than 9 friends. What we're seeing here is a new restriction that Facebook put in since the latest issues surrounding the Cambridge Analytica breach. Now you can only look at people who have also used this website before. So these are all my developer friends. This is a data scientist at Facebook, for example. Why are we doing this? We're doing this just to get a sense of how you might pull network data from an API. We got our credentials when we logged in. We put together a URL that made a request, and we got some output down here. And the data looks a little funny. It's not in a neat CSV spreadsheet like you're used to. It's in a format called JSON. And if we browse that a little bit, you can see it's full of these curly brackets and commas. There's different names. And then there's a lot of IDs for different people. One of the challenges in working with web-based data is learning how to parse this type of output into something like, you're all by now familiar with what an edge list is, for example, into something like an edge list. And so we'll work through that in just a second. Any of you who follow the news know that this landscape, the field I like to call computational social science, it's become a little bit of a minefield lately because of issues around privacy, right? So I can't go and get Kevin here's friends, right? Because we're not yet friends on Facebook. He hasn't accepted my friend request yet. That's limiting, right? If you wanted to study, say, the transmission of health behaviors across a Facebook network, you would need to be friends with all those people, or you'd need to maybe write an app that requested permission to get authentication to access their account. And that's what's happening anytime that you install a new app and it says you're agreeing to share X, Y, and Z with this app. That's one way to get these data. And if you're interested in that type of approach, I have a number of articles, one in the Proceedings of the National Academy of Sciences and another in Sociological Methods and Research, that describe how a model for doing that type of research. But because today we don't have time to build an app, we're going to work with a much more easy to use and easily accessible resource, which is Twitter. So if you know Twitter, you know that most people have a publicly available account. So if we go to, let's go to Duncan Watts' Twitter account. And so here we can see everything we see on this page, we could scrape from Twitter's API. We could get we could get the text of all of Duncan's tweets. We could get the names of the people he follows, the names of the people that are following him, kind of a directed in-degree, out-degree network, if you will, everything he likes, and so on, and information about him, his website. And for many people, sorry, not many, for a small fraction of people, you can also get the GPS coordinates where they live. Here, Duncan has very generously shared that he lives in New York. And some people also geocode every single tweet that they make, allowing you to pinpoint where those tweets are happening. Quite unfortunately, it's about 1 in 100 people that shares that data. So if you're suddenly envisioning a study of using GPS and linking it to Twitter, you should know right away that there's real limitations in who shares that type of data. But I'm going to show you a way to get it just in case you do have a population where that selection issue might not be so grave. OK, so we're going to work through an example where we build a network of Twitter. And in order to do that, the very first thing we need to do is, and this is a little awkward, this will seem a little strange, we need to create an app. We're not creating an app that's going to, for example, let you share your favorite New York Times news story. We're going to create an app solely for the purpose of scraping data. And so to do this, and it's a little strange because most of the people working with APIs are in fact web developers or computer programmers who are building apps. That's why we use the nomenclature app here. So again, if you would like to follow along, you're welcome to follow through each step with me. But because I'm going to start going really fast and a lot of new stuff is going to come from a lot of different angles, probably for many of you, it might be most useful to kind of lay back and watch and then try to revisit with the code that's in the Dropbox later. Also because you'll have to, A, have a Twitter account, and then even if you have a Twitter account, you'll have to register as a developer. So if you wanted to, if you want to follow along, I'll give you a quick kind of demo. I'm going to apps.twitter.com, and that's going to take us to this page. And I'm logged in here using one of my Twitter accounts. And if you wanted to follow along, so you'd have to first log in here. You have to share your phone number. The reason for that is because Twitter's trying to prevent hackers from building sinister apps that can just go around, and someone could build, say, 100 apps. And by using two-factor authentication, requiring you to kind of show that you're a person with a phone, they prevent that, right? So anyways, once you log in, you can go to Create New App up at the top right here. And of course, Twitter's messed up. There we go. OK. And now, and again, this is going to seem strange to many of you. It was strange to me the first time I did it. We need to give our app a name. We need to give it a description. And you can call it whatever you like. You could call it Duke Health Networks app. And then you could say app to scrape followers. Twitter does not care. You could put in any website you like. You don't have to put in your website. But one very important thing is this callback URL. This is a place on the web where your app is going to talk to the Twitter API. And so we need to put in a sequence of numbers that's in the annotated code here into that box. I'm not going to do it now because I'm going to log in using other credentials. Okay? And if we go back to that Twitter page, then you have to agree to Twitter's terms of service. There's important information in here. I understand you're going to talk about ethics tomorrow. Most of the data we're going to collect today is publicly available. And many people are content to then say, OK, well, that's fine. Let's just collect what we want. I think an important thought experiment to do is to ask yourself whether the people whose data you're scraping know that you're scraping their data. And my guess is at least some significant population of them do not know that, which raises some issues around informed consent. And so people in this field of computational social science are still working out the proper workflow, but mine has been to anonymize folks where there's risk of identification. OK, so if you click your Twitter application, I'm not going to do it because I've already got an app. And my app is actually living over here on my other browser. This was for another undergraduate class I was teaching where we were scraping the web pages of celebrities. And what you'll see here is your app has the name you gave it. It has a bunch of stuff up here. Most importantly, it has your credentials. Here they're called keys and access tokens, and different APIs will have different names for these access tokens. And what they are doing is essentially telling Twitter who you are and what data you're supposed to have access to and how often you can access that data. Other APIs might have even additional security fields, but in the case of Twitter, that's what's going on. One of the strange things about working with APIs is that every API uses different jargon. So whereas on Facebook, we talked about access tokens, right? Twitter also has access tokens, but it also has something called a key. And then those queries that we were making where we said me/friend, those are going to vary for every API as well. So on Twitter, we're going to have to use different terms as well. So in a sense, it's kind of like learning a new R package. It's like you have to learn an API and what types of queries and terminology are necessary to understand it. And APIs, by the way, are not just repositories for data these days. APIs can, for example, transcribe voice data. They can produce visualizations. APIs are just things that live on the web that can do stuff for you in a very imprecise way. But really, that's becoming increasingly true. OK, so if you're following along, you'll want to grab your keys and access tokens. I keep getting off of here because I don't want my access tokens floating up into the ether on the web. And you shouldn't either. So if you are going to put this code in a public folder, be aware that if you paste those data, someone else could take your credentials and then do whatever they want with it. So be careful with your credentials. That's why in the code here, you'll see Leanne, who wrote this little snippet here, has said this is an example of an API key, not her real key. And so if you're following along, you'd have to put your key here in between quotes. And often people will, for example, forget to trim a space off the beginning or the end of the string, or they will accidentally remove the last character or something of that nature. And you'll need the key. You also need the secret, which is also defined on that page that I just showed you. And we take all of these things, which we defined here as character objects in R, and we're going to use a package called rtweet. So if you're following along, you're going to want to install .packages rtweet, which will take about 20 seconds. And then, of course, you need to load that rtweet package. And once you've done that, then this create token, bless you, function will become available to you. And the create token function allows you to pass those string fields that you just defined above in the code, the app name, the consumer key, and the consumer secret. And when you run this line, you'll then start the process of authenticating yourself vis-a-vis Twitter, and then you'll be able to make queries from Twitter's API. So I know better than to ask if all the people who are trying to follow along are able to follow along, because that tends to slow down these type of things because I only have 45 minutes. I would only ask that you raise your hand, and both Joe and Leanne in the back there are available to help you if you're having trouble logging in or getting your credentials going.
Do they charge money for this?
Do they charge? Oh, yeah, sorry. Feel free to interrupt me. This service is completely free, but many APIs are not free. So it depends. Facebook is free, Twitter is free. Sometimes there's issues. Some types of things are not free within a single API, and there your credentials will be transformed based on what you've paid. That's another way that credentials are used to restrict access to data. Some APIs work per query. It really depends on the API. But this one is fully free. Yeah, thanks. Any other questions before I go on? OK. Great. So if you're following along and you've authenticated, we can do we can do a few little parlor tricks here. OK, didn't load our tweet. OK. So what I did in this first call is I searched Twitter for 100 tweets about networks. This is this search tweets function. If we looked at it in its guts, which you can do actually for those of you who don't know, just by running, if I click Control Enter now, we'll see the actual source code for this function. What it's actually doing is taking the name of our query, networks, and another argument, we're asking for 100 tweets, that's what the N means, and it's stitching together a really long URL that says something like apps.twitter.com/ user credentials / blah, 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 and then it's putting our query. And then it's returning a JSON file into the web. We're not seeing any of this, right? And then it's essentially scraping that data from that web page and putting it into a neat data frame for us to analyze. So this one small function is doing a ton of stuff. And we like these type of R packages because they're efficient. But if you get really into this field, you will probably get to the point where you have to write your own custom API queries. And when you're in that landscape, so for example, if there's a new API that comes out in the field of health, and by the way, there's tens and thousands of APIs out there, and dozens come online each day. So if you're an entrepreneurial graduate student, postdoc, junior faculty member, these can be really powerful new well streams of data if you're out in search of new data. So there's some good resources online. If you just Google database of APIs, you'll find a few large websites that keep track of APIs and categorize them by field and so on. OK, bit of a diversion there. What I'm showing you is just a simple way to make your first call to an API. Nothing to do with network data structures. We're simply getting network data. So I'm going to do it again here. This time I'm asking for more tweets, 1,000 tweets. Can people see in the back, or does this need to be bigger? OK, great. And I've also asked it not to include retweets. If I didn't do that, it would start populating this data frame that now appears on the right here with tweets. And so now, as you can see, we've got a really large database of tweets, people talking about social networks. Obviously, they're not all talking about Harrison White or Duncan Watts, but this is just a proof of concept to show you how you could grab the data. And you'll also notice that this handy function that we use, the search tweets function, has not only grabbed the text for us, but also the screen name, user ID, a timestamp, ID for the text, and a bunch of other fields, including hashtags, which people use to queue particular subjects on Twitter, for those of you who don't use Twitter. We can even collect the visual data here about the tweet. If you get really into this field, some of the state of the art is using image recognition to then infer demographic characteristics from the people in the tweet. And, surprise, surprise, there's an API that helps you do that. And there's many interesting efforts afoot to code not only race and age with pretty good reliability so far. I mean, we don't have the definitive study yet, but also gender. So there's a genderized package in R where you can pass the name of any user and try to infer their gender. So I know there's lots of folks interested in demography here, and those two things could be useful. OK, so we've got some text-based data. Where are the networks? First, let me just show you a little more functionality. Let's just simply make a plot of the data we just collected. Let's see how popular the subject of social networks is over the last 9 days. Here I'm using a function called tsplot for time series plot from the rtweets package. I assume people have learned a little bit of ggplot by now. This has a ggplot backend. And what we're seeing here is the frequency, binned in increments of 3 hours, tweets over the last 9 days. Or sorry, not 9 days, 1 day. And so this is probably you guys right here waking up, right? Again, interesting proof of concept. If we wanted to tweak this with color and so on, we could get into the aesthetics of the ggplot commands here, but we don't have time to do that now. How many folks are interested in GPS, geotagging, these types of subjects? At least a few people. OK, let me just show you another interesting feature. Again, I'll get to the networks in just a second. Here we'll do our same search, but now let's only look in the USA. Here we're using a new argument in our search tweets function called geocode, which lets us look up the coordinates of any named entity, here the USA, but we could do North Carolina or wherever. And now we're asking for 1,000 tweets about social networks that were geotagged either in the person who tweeted the message's bio, or their description of themselves that appears to the left and underneath their visual of their kind of headshot, or they've tagged their actual tweets. And so we're going to pull that data again. And we're now scraping 1,000 web pages. And soon we should see another data frame over here called US net tweets. And then we see something very similar, right? A bunch of tweets here. But then if we come all the way over to the right, we'll see very few of them, as I mentioned at the outset, are enabling geotagging. So if we then go to plot this, let's see, here in this, now, so that was people who willfully offered their GPS data to anyone, right? Now we're going to use something called named entity recognition. This lat-long function is actually trying to extract latitude, longitude data out of any named entities, like the name of a store, the name of a state, whatever, in the tweets, and is now going to give us its best guess of where all these people are. I don't think it ran either, yeah. US tweets, yeah, I called it something else. US net tweets. Thank you. OK. So let's try this again. Yeah, we still don't have a ton, but we have more. So these are latitudes and longitudes that are being guessed by this function that we just used. And so now, those of you who are interested in GPS, you're probably not doing any GPS mapping. So just suffice it to say, this is using the maps package to plot these points on the map of the United States. Really tiny. We could, let's see, where is this? I think we want to change this here. or actually, that's the size of the points. I think we need to define our map somewhere else. Anyways, I promise with a little bit of Googling of the map function here, we could locate the argument we want to make that map bigger. I just can't remember what it is offhand. I'm trying to see now how many of them are coming from North Carolina. It's kind of hard. At least a few, right? Okay. Okay, so let's get into some networks, because that's why we're here. Again, I was just trying to give you a proof of concept of how to pull data from Twitter. Twitter is great for folks interested in networks because we can get very, very complete network data. Now, when I say complete, I mean the complete Twitter network, right? It's not the network, the underlying network that connects all of us. It's people who have willfully followed each other on Twitter. And that's a hugely important distinction, right? If we wanted to study, how people are getting jobs, or whether people are going to support each other in a difficult time, right? Twitter's probably not that network, right? But if we wanted to study the spread of information about a virus or something like that, Twitter might well be a really great source. But probably at the end of the day, and this is just a big kind of take-home point from the field of computational social science, probably the best studies are going to do a hybrid strategy where they both collect this data and then also supplement it with some other data set or collect, for example, survey data. So here we can get the timeline of an individual user. I had to quickly make a choice about which type of network to build on Twitter. And for those of you who are familiar with Twitter, there's these things called lists, which kind of group Twitter users into meaningful categories. And so this sociologist, Phil Cohen, has made a list of sociologists. I'm a sociologist. And so I decided to grab his lists of sociologists using this lists users functions. And what this is showing is all the lists that he maintains. Maybe some of you are on the emerging sociologist list. I don't know what that is, but it sounds important. We're going to grab the sociologist list. This is as many sociologists as we could find on Twitter. And so we need the ID of the list. That's why I highlighted that. Now we're using another function. And by the way, I'm throwing a lot of functions at you. And if you want to learn how each of these work, the rtweets package has its own web page, which is pretty well documented. It describes how to use each function, exactly what they're doing, and allows you to browse the source code. But here, now this call I'm making is saying, go find this list with this ID and give me the names of all the members. And so when I did that, it created a data frame over here. Now those of you who are sociologists might recognize some of these folks. We haven't been able to get Jim on Twitter yet, so you won't see him there. But let's see, Mike Hout. Okay, many people will know Mike Hout, right? Okay, fair enough. Yeah, I don't really like that I'm on Twitter either. Okay, so we've got a sampling frame here, and again, this is a silly kind of toy example. Maybe some of you are interested in following, networks of people who abuse drugs or alcohol or something like that, and you'd have your own way of figuring out who those people are, right? You'd of course need to get their Twitter IDs, which is non-trivial. You could imagine some creative ways combining, for example, respondent-driven sampling or something like that to populate those type of networks. Here I very conveniently just found a list of people I know share this affiliation. Okay, so now we want to get their networks. We want to see how all these people are connected, who follows who. And so we're going to use the get followers function within the rtweet package. You can see the structure here. We give it a username or a Twitter ID. Twitter keeps track of people both with string variables and numeric variables. This is going to ask for 5,000 of their followers. And then there's a bunch of other parameters that tell it what to do in various circumstances where the data aren't in the right format, essentially. But the default settings, most of the time, are going to work for you. Here's our list of sociologists, and here's their screen names. And we're just going to try to get the followers for the first sociologist on that list. That's what these square brackets are doing here. Can everybody see in the back? Still okay? Okay. And so now we've created a new object. These are the user IDs of the people who follow a sociologist named Ann Morning. But that's not really what we'd ideally like. We'd like to know more about who those people are rather than just a simple number. Yeah?
Whenever you're taking
Oh, this N here, you mean? Yeah, it's a good question. It depends on the query. So when we did search tweets earlier, what we were seeing was a mixture of both recent tweets and popular tweets. But there's a field, for example, in that function that will allow you to specify whether you want to get popular tweets or recent tweets. Here, I'm not 100% sure, but I'm 90% sure it's pulling the most recent 5,000 followers. And if you wanted to get more, you'd obviously just increase the N. Without getting into too much detail, the reason that we have to do this and can't just say, give me all the data, is sometimes there's a ton of data. So Duncan, you saw, has 15,000 followers or something like that, right? And so that doesn't fit all in one page neatly. It would take forever for it to load. It would take a long time to scrape it. And so Twitter essentially returns that data to us on multiple pages. And at the bottom of every page, there's a link that says, here's the link to the next page of data. And this is called paging through the results of an API query. And so what you're essentially doing, and what this function is doing for you, is going to the bottom of that page and clicking that link to get more stuff. But again, all APIs differ, and this is the real challenge in this field of learning how different APIs work. They have some general similarities, though, and once you learn one or two of them, the third one's a lot easier, typically speaking. But as with any tool and anything in the open source world, right, some things are better documented than others, and that can be really frustrating. There's really nothing to take the place of hands-on experience like this where someone's answering exactly this type of question, right? There's so much domain knowledge. What is a credential? Before this lecture, maybe many of you thought your credential was your university degree, right? You didn't even know what to do. I didn't when I first got into this world, right? So yeah, that's maybe more of an answer than you wanted. Here, I'm using another function, which is taking those user IDs that we got and then extracting more data about those people. It's the lookup users function, and this gives us their name instead of just their user ID, their screen name, where they describe their location in their bio, a description of who they are, the URL, whether or not their Twitter account is set to public, number of followers, and so on. Just a bunch of data here. And again, here's the profile URL that we could use to then do that type of machine learning analysis of the images that I was talking about earlier. Okay, so that's the data we want, but that's just one person. If we want to build the entire network of all these sociologists on Twitter, and again, use your favorite example. For many of you, it won't be sociologists. I'm not even sure I want to know about sociologists. You need to write a loop. How many loops have we written in the first 2 days here? 0. Oh, God. OK. And how much time do I have left? Like 10 minutes? OK. So we won't have time to learn exactly how loops work. Essentially, a loop is a way of iterating again and again and again to do the same task. And what we want to do is take each person on our list and grab the names of all their followers and again and again and again for each person on our list, right? And in the end, we want to wind up with an edge list that says so-and-so is connected to so-and-so, so-and-so is connected to so-and-so, and so on and so forth. So a loop, I want to make sure I leave time for questions too. A loop needs a place to store stuff. So what we're doing here is creating an empty data frame. I'm calling it socinets. And we create an empty data frame using this null argument here. And now you'll see we have a data frame with no rows over there. All right? And we need a place to put the data we're collecting, because each time we pass through our loop, we're going to say, here's some data, and now put it in my data frame. Here's some more data, put it in my data frame. There's a little bug in the code here that I don't have time to explain why it's there. Please, if you're following along and want this to replicate, replace that 98 with a 1 here. And what we're saying here is we want to do something about 1,000 times. We're going to start with the first name in this data frame of sociologists, and then we're going to end this little colon there saying to the end of the data frame, the number of rows in the data frame. So this is actually, if we run n rows sociologists, we'll see we're actually running 1,083. So we're saying, do all the stuff we're about to tell you about 1,083 times. Now, the very first thing we need to do is to make sure that we're allowed to get that data, that we haven't asked for too much data within too short a period of time. This is the thing called rate limiting that I was talking about earlier. If we ran our code right away, we would get about the first 15 accounts, and then Twitter would say, you'd get a funny kind of error message that would say something like OAuth error or 404 error, something, some kind of web speak. What that is saying is you asked for too much data in too little time. And so what we need to first do is figure out what our rate limits are. Our rate limits depend on a lot of things. Sometimes we can pay to get greater access to more data. That's not the case in Twitter, but in other places it is the case. Sometimes it depends on the time frame being used, right? Twitter uses 15-minute increments. Other sites use a day. And so if you make too many calls within one day, you've got to wait till the next day or move to another IP address or wherever, however you're being defined in order to get more data. And keeping within the rate limits and the terms of service of these sites, I think, is really important. For those of you who are young scholars starting out and contemplating a large data collection, imagine this scenario where you violate the terms of service, scrape data you're not supposed to, or maybe too much data at once, and 3 years from now you get a cease and desist letter from Twitter that says, sorry, you can't use your dissertation data, right? Really bad scenario. So respect the rate limits, learn about them. You can find out what your current rate limits are using the rate limit function here. And what that's doing here is producing a data frame that tells all these different types of things I can ask for on Twitter and how many I can do within what period of time and when that period will reset. So again, without getting too much into how a loop works, essentially I'm saying figure out how many things I'm allowed to get. Specifically, I want to know about how many requests for followers I can get. And then here I have an if statement, which says if the statement within these parentheses is true, then do this stuff. If this is not true, then do this stuff. And so what this says is if the object I described up here, which counts the number of remaining queries I can make for that field, is 0, then sleep for 15 minutes. 15 times 60 seconds, right? The syssleep command simply tells R to pause for a certain number of seconds. Okay, so every 15 minutes or every 15 API calls, we'll get this code would print sleeping, and then it would not do anything for 15 minutes. We also need to make sure we don't try to scrape people whose accounts are not set to public, because that will throw an error in our code. And so here we have to say if the person that we're looking at does not have a protected account, then scrape them. It would say true. If they did have protected accounts, we would put true there. This is just a kind of Boolean statement here. OK, and so now we basically essentially reproduce the steps we did above. We get the followers. We get the names and the details of the followers. And in this step here, we make an edge list, which here is these are the names of all the people followed by the focal person whose data we're scraping. And then here is just the person's name, the same number of times that the length of that list of followers is. So it would say Duncan Watts so-and-so, Duncan Watts so-and-so, Duncan Watts so-and-so, just like any edge list that we'd want to use in network data. Is that clear? OK. And finally, this is that blank container that we created above. And here, we're using the rbind package, which simply appends a data frame again and again and again with new data. And when we're finished running this, we'll have a data frame called socialnets that's an edge list of everyone in our list and who they are followed by, in this case. We put print I down here. This is kind of a bit old school. This helps us debug, so when something breaks, we can then write I and run I and figure out which line threw the error. It also helps us get a sense of how long things are taking to run. Here, I stopped at 185 and saved another file. This code actually takes about a day and a half to run because of rate limiting. So you can extrapolate from that if you're picturing getting hundreds of thousands of Twitter accounts, network structures. That's an obvious limitation. And then I won't go through. I think you're working on visualization and data management elsewhere. This is simply some code that then takes that edge list and produces a Ggraph. Have you guys used Ggraph yet? Yeah. OK, great. All right, this is trial by fire. So OK, so this would produce the network that I've been describing. So I could go on about a lot of different stuff. We here at Duke, we're doing a lot of exciting work in computational social science. But if I can just plug my summer institute, during Jim's summer institute, really quickly. This is an event that I run with Matt Selganik at Princeton, and this URL up here is compsocialscience.github.io/summer-institute/2017, or you could just Google Summer Institute in Computational Social Science. Great, great. And I'm doing this not because I want you all to come to my institute and not Jim's institute, but because we have on this site, and make sure if you're Googling it that you're on the 2017 site and not the 2018 site. We have, for every lecture that we gave, this was last year, both me and Matt and a number of really great speakers, video of every lecture, code and slides for every single lecture that covers everything from ethics and what is computational social science to the topic I talked about today, collecting digital trace data, to automated text analysis, which is another one of my areas of expertise, all the way up through surveys in non-probability surveys in the kind of computational social science area, mass collaboration, field experiments, and so on and so forth. So I hope that this will be a good resource for anyone who wants to kind of learn more and follow up on what you might do with the data that I showed you how to collect today. And again, I hope that code I sent you will give you enough to, if you want to take the next step. The only other resources I would point you towards are Stack Overflow for coding help, and GitHub, where a lot of conversations about how to get these things working happens. So should I open up for questions, or am I out of time? Or questions? Jim.
Can you tell us a little bit about your autism work by way of example of it?
Yeah, sure. Sure, yeah. So my interest in health is really in health communication. I've done a number of studies designed to examine how advocacy groups, health advocacy groups generate viral social media conversations. And a lot of the work has been with Facebook. Specifically, if you're familiar with Facebook fan pages, so most organizations, especially advocacy groups, have a presence on Facebook called a fan page. And those data are publicly available. You can scrape a lot of them and get a lot of information about what they're posting about and so on and so forth. But about 5 or 6 years ago, I had the idea that a lot of that data also had inherent limitations, right? We couldn't get a lot of the data we wanted the most. Things like more sensitive data, or we could maybe map the number of followers a group had, but how much money do they have, or how many staff do they have? We couldn't answer core questions about alternative explanations of the phenomena that we were trying to study, which is again kind of the viral diffusion of social media posts. And so I created an app, which is no longer online, called the Viralgorithm, which allowed nonprofit groups to get a free audit of their social media content in return for completing a survey, which we then could link to their Facebook data, giving us, I think, one of the first applications, hybrid applications of so-called big data with survey data, and that's a model that I've now reproduced in a number of studies. The findings have to do with a lot of the properties of discourse, and specifically which types of cultural messaging are most effective, when, where, and why, and also social psychological factors, especially the ebb and flow of emotional language and channeling the diffusion of discourse about health advocacy issues on Facebook. Yeah. Mm-hmm.
Given what you said at the beginning about the ethical limitations of a lot of this work, I was wondering where you see the future of this field of computational social science in the next 10, 15 years.
Sure, that's a big question. So, first of all new fields have ethical issues, I think. I mean, and honestly, a lot of the big high-profile cases, not so much the Cambridge Analytica case, because I think that was really fraught with a number of ethical issues, but the emotional contagion study you may have heard about, where the concern here was that Facebook experimented on people without people's consent. According to Facebook, we sign our terms of service. That's a form of consent, right? If you speak to the authors of those studies, those were very well-intentioned studies that were not out to abuse it. Now whether they did is a huge question. But I think the take-home message, and Matt, my collaborator Matt Selganik, has a great chapter of his book, Bit by Bit, on ethics that walks you through this controversy and many others, it really shows that the field has to hold itself to a higher standard than conventional IRB regulations. Because half the time you go to IRB and they say, we don't know. Is it public? I don't. And so I think that's why my rule of thumb is to hold ourselves to a higher. As to whether this is now a field full of landmines where one can't do research, I think that's emphatically not the case. So if you're following the Cambridge Analytica story, many of us thought Facebook would turn more inward and release less and less of its data. Instead, it's announced a major new RFP with support from 6 foundations and 2 prominent scholars to open their data and to allow people to access their data sets. You can read about that both on Facebook's their policy team site, or you can search for a paper by Gary King and Nate Pursley that describes how that process is going to unfold. I also think, just in the period that we're in, look at the historical rates of survey response rates, right? I mean, those aren't going up. That's my bet anyways, right? So what's going to take over? Are we going to be content when our response rates dip into the 1%, which many surveys are around there right now? And again, I've come to conclude that this type of data is not a panacea, but it's a necessary ingredient in the solution for years to come. So my big bet is you'll see more and more work, and this isn't the end of the story, but hey, that's just my view. Yeah, John. Yeah.
Silly question. Do you have the diffusion data of your own app?
We did track it. In fact, we randomized it, and our goal was to see whether groups that used the app did better than those that did not. And has anybody ever heard of a strings as factor error here? This is like the nerdiest joke ever. Okay, so in R, a string actually has an identity that's numeric and that's a character value. And if you run an analysis on a factor variable, you can actually be analyzing the numeric values instead of the string values. And 4 weeks later, we discovered that our exciting finding about the power of our app was actually complete noise. And so it did not work in the sense of helping them get more followers. Yeah, we don't, we can't. These are kind of intent to treat effects. We don't know if they took our advice, acted upon our advice, all those things. So it was also a pretty unruly time. This was 5 years ago, and who knows what was working and why it was working. Yeah, sir.
How do you analyze content? It's like we were talking about the emotional content of the
Yeah, sure.
Is it automated or is it?
Yeah, so there's a number of tools. I mean, I would invite you to check out the lectures here on automated text analysis. Broadly, there's a few classes of analysis. One is a dictionary-based approach where people assign a meaning to a word. There's a popular tool called linguistic inquiry word count that social psychologists developed. There's something called sentiment analysis, which is a very similar approach. Sometimes it involves somewhat more sophisticated forms of machine learning to make classifications of text as angry or non-angry. There's topic modeling, which is an unsupervised approach that derives latent categories from free-flowing text. And then selfishly, and this is really, but many of you probably don't know that Jim is also one of the original pioneers on text networks, which is a field where we kind of take text, because Jim has done so much. This is actually one of my favorite things Jim has done, just to embarrass him a little bit. We can treat a text as a network, right? And then we can run community detection on text and think of finding patterns in text that way. And this is an R package that I've written called TextNets that will allow you to do that type of analysis if you're interested. And essentially, it'll read in a document and produce a network out of it. So here is the State of the Union addresses, for, again, something's wrong with the resolution here, of US presidents mapped in terms of how they, similarities in their texts. So we can have a lot of fun with text and networks. Do I have time for one more? Yeah.
Hey, Chris.
Yeah.
There's a lot of computer scientists getting into this area.
There's a lot of what about it?
Computational scientists or computer scientists getting into this area. What is as a sociologist, where do you see the biggest pitfalls and most egregious misuses of this approach from a scientific perspective?
Yeah, I think we definitely need more social scientists on board. The field of computational social science is at risk of being hijacked by people who aren't social scientists. who think, just because they have data that describes people, that they're then in a position to produce theories of how people behave, and that's really dangerous. And honestly, it's been bad PR for the field too, because there's a number of silly studies that say, here's a network of people talking about the Arab Spring. Twitter caused the Arab Spring, right? And then obviously any good social scientist can see any number of reasons why that's a silly thing to say. But in computer science or physics, that data is kind of the given, right? When we perceive given the data generation process is much less important, and that's where social science, I think, has the most important impact. But also just because most of the data is generated by people, and it's a new lens, these digital trace data, to study human behavior. And so if we're not all over it, I'm personally really concerned about who will be and what type of explanations of human behavior they'll come up with. That isn't to say that we shouldn't work in tandem. In fact, our Summer Institute draws people from about 16 different fields each year, and I think that's because there's so much interest across fields. The trick there is aligning incentive structures, right? Computer scientists want to publish in conference proceedings, 2 weeks from now, and sociologists want to publish in ASR 3 years from now, and so, sociologists don't care about conference proceedings, computer scientists don't care about ASR, so that's an inherent challenge. Yeah. Mm-hmm. Overlaying.
Adding any sensor data to something like Twitter.
Yeah. Yeah. It's a good question. Sensor data, for those of you who couldn't hear it, adding sensor data to Twitter data. I think the easiest way to do it is if you have a survey in the field where you're collecting sensor data, just ask those people what their Twitter handles are. Of course, you need to describe in some kind of informed consent dialogue that you want to get their data and link it, and importantly, to link it to that data. But that would be pretty simple, right? Then you could make your API calls with their Twitter handle, and then the only trick would be merging your original data set with the Twitter data set. But that's a pretty straightforward way to do it that doesn't require any significant programming, or for example, embedding the Twitter API in your data collection or something like that. A big question, of course, is how many people in your survey are on Twitter, versus Facebook versus whatever. But of course, there's an R package for analyzing Instagram, and there's an R package for analyzing the New York Times, and really, I mean, whatever subject you're interested in, I encourage you to Google the name of your subject and then API, and I think you'd be surprised to see how much data is out there. Yeah. Anything else?
Thank you so much.
Great, thank you.